We just finished going over types of factoring and how to solve by factoring, as well as completing the square to find the vertex of a quadratic function. Now let's go over what happens if we cannot factor, and if we're asked to find the x-intercepts or the roots, or in a word problem question, the distance traveled or the time that it hits the ground. Let's take a look at an example. Let's say that we are kicking a football and we are measuring the height in meters and the distance traveled horizontally also in meters. So those are the two things that we're looking at. And our equation of the football that's being kicked on the field, football kicked, follows this path. H equals negative 0.2 d squared plus 6d plus 0.5. So this equation is in standard form, and in standard form without doing anything to it at all, there's a couple things we can see. The first thing we can see is that it, rightly so, opens down because the ball is going to be going up and coming down. It also shows us that it doesn't start exactly at the origin. This positive 0.5 is the y-intercept. So when we're kicking a football, sometimes they drop it and kick it when it's still in the air. It's starting off at half a meter above the ground and it's going up and coming down. Oh, forgive that squiggly line there. It's supposed to look like a nice smooth curve, but I'm having a hard time. Okay, so we have a y-intercept of 0.5 that's given in the equation. If it was not C in standard form, if it wasn't given to us in this form, we could also sub in x equals 0 in any equation to find the y-intercept. In this case, it would be d equals 0 because we're looking at d and h as our coordinates. So we know right now that the y-intercept is 0.5. A question that we could be asked that would require us to say that would be the height from which it's kicked. So height from which it is kicked is 0.5 meters. Okay, so that's kind of the first thing that we could have to find out, and it's just reading it off of the equation. That would be a 1-mark question. We could also be asked the maximum height. So what's the maximum height of the ball and when it occurs? So, and when it occurs. If we were asked to do that first, before we had to find any roots, we would likely complete the square. So in this case, we would just take that equation, we complete the square, factor out the 0.2. Remember, you're dividing both of these by negative 0.2. So it would look like this. Divide a positive by a negative and you get a negative. 6 divided by 0.2 is 30. And we would be halving and squaring the 30. So 15 squared is 225. Sorry guys, this is getting a little bit messy there. And then we're going to factor and move. We're going to factor this trinomial. D minus 15 squared is factored form. We're going to multiply negative 0.2 times negative 225. And it's going to go outside of the brackets. Remember, please, please multiply the number in front of your brackets by that negative product that you've added into the equation. So 225 has to be multiplied by 0.2 before it goes outside the brackets. Negative times a negative is a positive 45. And if you add the 0.5, so 45 is just that being multiplied, and you add the 0.5, and you get 45.5. So if we were asked for the maximum height, this right here is the maximum height, 45.5 meters or feet. It's an imaginary equation that I made up, so it's probably a little high, but that's fine. And it occurs at a distance, a horizontal distance of 15 meters. Probably I should have said, instead of when, where does it occur? Right? At what distance does it occur? And the answer is the distance of 15 meters. So those are the two questions that we could easily do right from the start. We also could have found the maximum height and when it occurs or where it occurs by finding the roots first and averaging them to get the vertex. Remember, whenever we're asked for maximum anything, we're finding the vertex. This means vertex. The maximum is the y-coordinate, and when it occurs is the x-coordinate. Okay, anything to do with the initial height is the y-intercept, and anything to do with when it hits the ground, how far it travels, where does it land, that all has to do with the x-intercepts or the roots. Oh, I can't separate this, that's so sad. Okay, so I'm going to copy the equation out again, and we're going to look at another example of what we could be asked. We could be asked to find out where it lands. Where it lands. Now, anything to do with it hitting the ground is asking us for the x-intercept, or the root. And ways to find the x-intercepts are either by factoring or by using the quadratic formula. So in this question, I would have to see if I could do that. If I could factor, I would want to factor. And if I couldn't factor, I would have to use the quadratic formula. I'm just going to briefly copy out this equation so that I don't lose it at the top of the page here. I'm sure there's a way to add more length to the screen, but I have not figured it out yet. So we're trying to find out where it lands or how far it travels. Does this equation look factorable? And when I look at the question, when I look at this trinomial right here, I have to see if there's a common factor. Now, you can divide negative 0.2 into almost anything, right? That's 1/5. So you're just basically multiplying these numbers by 5. So you easily could factor out that common factor. You could use your calculator. If you can't do it in your head, that's okay. If you wanted to divide by negative 0.2, you get d squared minus 30d minus 2.5. That's clearly not factorable because there's no factors of 2.5 that subtract to 30. It's just not possible. So we're not going to factor. We're always going to try to factor, though. It takes you 1 minute to try it out. If it doesn't work, just forget about it and move on. When we can't factor, we have to use the quadratic formula. Can't factor, quadratic formula. Remember that your quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to get the formula, but you have to know how to use it. So we're going to take these numbers. We're going to take negative 0.2, 6, and positive 0.5, and we're going to plug them into our formula. So x equals negative b. That looks like a b. Let's make it look like a 6, shall we? Plus or minus the square root of b squared minus 4ac all over 2a. Please don't forget your signs. That a value is negative. It'll mess up your whole answer if you put a positive 0.2 instead of a negative 0.2. So what are we going to do? We're going to multiply it out. In your calculator, you're going to type in 6 squared or 36 minus, you're going to make sure that you use brackets. And again, you can do this in your head, but if you can't do it in your head, you're going to multiply 4 times 0.2 times 0.5 in your calculator. Right, that's 0.4 because this is the same thing as saying 0.1 times 4. And you're going to add, I'm going to say add because we've got a negative times a negative is a positive. You're going to add that to 36. So simplified equation, negative 6 plus or minus the square root of 36.4 over negative 0.4. Those are the roots. We're going to do it once with a plus sign and once with a minus sign to get the two x-intercepts. So let's move this up here. One x-intercept is negative 6 plus root 36.4 over negative 0.4, and the other one is negative 6 minus that square root over negative 0.4. And they both have to be worked out in your calculator. Okay, every single time you use the quadratic formula, you should get a very messy answer. That's what happens. We don't get nice answers because if they were nice answers, we should have been factoring. Okay, whenever you can get a very easy answer or a fraction or an integer answer, that means you should have been factoring in the first place, which is not really a great thing if you're spending time using the quadratic formula. So if you use a plus sign, you get negative 21.1 approximately. And if you use a negative sign over here, we get -6 minus the square root of 36.4. When I type this in my calculator, I'm going to make sure I push equals at the end of right there, at the end of the top. Press equals, please and thank you, because if you don't press equals at the end of the top of the fraction, the entire numerator, you push equals in your calculator and then you divide by -0.4. If you don't push equals in your calculator, it's going to mess everything up. So make sure you push equals in your calculator, and the other answer is 30.1. So in this case, our ball has traveled 30 meters before it lands on the ground, or 30.1 if you want to be exact. I made up this equation, so it's not a beautiful answer, but a lot of the word questions are like that. So the negative number is not going to be used. It's inadmissible because distance and time have to be positive. Distance is positive, so we're not going to use it. Some of you on your test were averaging these out. You were adding them together. You were finding the difference between those two numbers. I saw lots of interesting things. If you get a negative root, just throw it out. It happened on the graph before our little experiment started. If this is our football being kicked, the negative number's way back here. It's before it's even started, so we're not going to worry about it. We're going to forget about it altogether, and we're going to say it traveled 30.1 meters. If we were asked to find the maximum height and when it occurred after figuring out these roots, we could easily average those two numbers together. And by averaging them together, we could find the axis of symmetry equation, and we could plug that back in to find the vertex. So that's another way of finding the vertex. A couple other things we learned in Chapter 6, and then we're done. We talked about how to use some shortcuts in Chapter 6 to find the vertex. We also filled out a really nice chart in our notes of how to find the y-intercept, how to find the maximum value or the minimum value, how to find when it occurs, how to find the roots or the x-intercepts. And we had a whole chart that talked about how to do those things and what they would look like in our equation. Definitely look at that chart. It's a really important page in your notes that's going to help you in your Chapter 6 booklet. Recall, though, that we did find some shortcuts to finding the vertex from standard form. If you wanted to, from standard form, you could use x equals -b over 2a just to get the axis of symmetry, and then you could substitute it back into the equation, and that would work out as well. So that's most of the topics we covered in our quadratics chapters, chapters 4, 5, and 6. You have some work to do. There is quite a bit of review in those sections. Do not skip questions because this is a huge portion of your final exam. There are questions also on your ISP. It's very, very important that you get this topic perfectly because in grade 11 you need to know everything from the quadratics unit as well. So if you have questions, please come see me, and happy studying.